Hello everyone, and welcome to the next video in the series. This video is a special video, and the topic of this video is going to be, I guess, controversial. It's on 7 reasons why you should ditch BEDMAS in favor of the analysis synthesis technique. And I would like to begin by noting that first of all, there is nothing wrong with BEDMAS. I've heard from a number of individuals who have shown me expressions that lead to the incorrect answer if they apply BEDMAS to it. And the case is that in all these situations, BEDMAS was sort of interpreted the wrong way. But that's one of its drawbacks as well. As we will see, it can be a confusing kind of an approach to working out expressions. Now, to begin, I'm going to list the 7 reasons, and then I will expand on each one individually. Reason number 1, BEDMAS is arbitrary. In fact, the question will be, why is it BEDMAS, not some other sequence of these letters? Number 2, BEDMAS is rigid. It leaves the impression that the sequence that you see in BEDMAS is the only sequence that works, and that's not the case. Number 3, BEDMAS is confusing. As I just mentioned, it's possible to come up with expressions that are confusing to work out when you try to apply BEDMAS to them. Number 4, BEDMAS is not really needed. You can actually use a different approach which relies on identifying the main operation in your expression and then working out its arguments. Number 5, BEDMAS is limited. We have no indication as to how to do roots if we have to perform operations or evaluate expressions that contain roots or logarithms or from trigonometry, sine, cosine, and so on. Number 6, BEDMAS is inefficient. Although there are different versions of BEDMAS, and this is another problem with it, it seems like every other person has a different understanding of what BEDMAS is about. Some people have followed BEDMAS in a way that's more efficient than others, and we'll look at some of the alternatives later on. And number 7, probably its worst feature is that BEDMAS is semantically deficient. One gets so much tied up in what to do next that one loses the big picture of why it is that one performs the operations in the order that BEDMAS sort of dictates. Okay, so with this introduction, let's now start with number 1. BEDMAS is arbitrary. So the question is, why BEDMAS? Why is it not some other sequence of these letters? For example, why is it not Badness? And the question is, could it be Badness? That's a funny kind of sequence. But the question is, could it be Badness? And the answer is yes, it could in fact be Badness or some other sequence of these letters. Quite likely B would have to come first. But the idea is that if you change the sequence, depending on the change that you make, you may or may not have to change the way you write an expression. And let me explain what I mean by that. We are going to take a look at an image on the right side. And this image lists 2 aims, followed by the manner in which we can achieve those 2 aims, following BEDMAS and Badness. The first aim is that we want to multiply 4 by 3, and then multiply 2 by 6, and then add the results. And for BEDMAS, if we follow BEDMAS, we can write the whole thing down as 4 times 3 plus 2 times 6. Because following BEDMAS, note that M, multiplication, comes before A, addition. So we have to multiply 4 by 3, which is what we want to do here. Then we multiply 2 by 6, which is what we want to do here. And then we add the results. And so writing it down as 4 times 3 plus 2 times 6, if we follow BEDMAS, will work. It will achieve the aim that we have here. However, the same sequence does not work for Badness. Because with Badness, you notice that A, addition, comes before M, multiplication. And that means that we would have to add 3 and 2 first, and that's not what we want to do. Our aim is to first multiply 4 by 3 and then 2 by 6, and then at the end add, not at the beginning. And in order to achieve our aim following Badness, what we would have to do is to place 4 times 3 and 2 times 6 in brackets, because brackets have priority over addition, and therefore we would have to multiply 4 by 3. We would have to do the brackets here, which achieves the aim multiply 4 by 3, and then we would have to work out the brackets here, which would achieve the aim multiply 2 by 6, and then we would add them. So both of them are capable of expressing our aim, but in different ways. Now, if we take a look at our second aim, this time we would like to add 3 and 2, and then multiply by 4 and 6. So we want to do 4 times the sum of 3 and 2, which is 5, and then multiply the result by 6. And in this case, for badness, the expression as I've written it here works pretty well, because with badness, again, addition has priority over multiplication, and that means that we would be adding 3 and 2 first, and that would be the objective that we have, and then multiply by 4 by that result, and then multiply it by 6. For BEDMAS, though, this sequence doesn't work, of course, because with BEDMAS, multiplication comes before addition, and therefore we would have to multiply 4 by 3 first. That's not what we want to do. And for BEDMAS, we would have to place 3 plus 2 in brackets, because B brackets comes before M multiplication, and therefore we would have to work out the brackets, and that achieves the aim of adding 3 and 2 before we multiply 4 by it and then multiply the result by 6. But the key is that we could have gone with BADNess. As you notice, we can express both of our aims using BADNess as well as BEDMAS. So the question stays, why did BEDMAS become the chosen sequence? Now, some people might say, well, it has to do with the order of complexity of operations, but then the problem is that it should have been BEDMAS, because if I take a look at order, now never mind brackets for a minute, there are exponents which are more complicated than division. Division is more complicated than multiplication. Multiplication is more complicated than subtraction, and subtraction is more complicated than addition. So it should have been BEDMAS, not BEDMAS, where addition, which is the easier operation, all of a sudden comes before subtraction, which is more complicated. And why is it in the reverse order? Even if it was BEDMAS, why is it in reverse order? Does it not make more sense to go with ASMDAB, which is addition, subtraction, multiplication, division, exponents, brackets? And by the way, what is B exactly? I guess that's another problem with BEDMAS, because B is not an operation. Brackets are not operations. Brackets are used to group certain entities. Now, of course, in BEDMAS, when we say brackets, it means perform the operations within brackets, work out the expression inside the brackets. But this is an extra thing that you have to keep in mind. So technically, BEDMAS is not order of operations, because B on its own, or the way it sounds, is not an operation. But if you interpret B as perform the operations within brackets, then maybe it does make sense. In any case, BEDMAS seems random. It doesn't follow the order of complexity of operations. It seems like the order is backwards, and the B, so long as you understand what it means, it's okay, but otherwise it can be confusing. Okay, we'll move on to number 2. Number 2, BEDMAS is rigid. So it leaves the impression again that this is the only way that you can sequence your letters. However, we could actually reverse the order of addition and subtraction, and we could also reverse the order of division and multiplication. And BEDMAS would end up being pretty much the same. So BEDMAS could be any of BEDMAS, where the order of addition and subtraction have been reversed, BEMDAS, where the order of division and multiplication are reversed, and BEMDASA, where the orders of both multiplication and division and that of subtraction and addition and subtraction have been reversed. And these ones will work just as BEDMAS does, with no need to change the way we write things. Let me explain how all of them work. On the right side, here we have a chain addition subtraction. We have -7 plus 3 minus 2 plus 8 minus 1. And in fact, with the approach that I propose, this is the way we see them. we have negative 7, and you can even think of this as 0 minus 7, which means that we have a subtraction here. And then add 3. Subtraction applies to 2, addition applies to 8, and subtraction applies to 1. Now, one thing that's important about this, one reason it's good to know this, is that you can actually change the sequence of what you see here by moving any of these terms around, so long as the operation that sits to its left is moved with it. So I could rewrite this expression as positive 3, so that would be the same as add 3, and then subtract 1, which is identical to subtract 1 here, then subtract 7, which is the same as subtract 7 here, subtract 2, the same as subtract 2 here, and then add 8, which again matches the addition by 8 here. And the argument is that both of these will give you the same answer. And in fact, if we were going to work these out, the first expression, we would get negative 7 plus 3, which is negative 4. Negative 4 minus 2 is negative 6. Negative 6 plus 8 is 2. And 2 minus 1 is 1. So this expression works out to 1. Now let's take a look at this one. 3 minus 1 is 2. 2 minus 7 is negative 5. Negative 5 minus 2 is negative 7. And negative 7 plus 8 is 1. And so again we end up with 1. And that should make sense, by the way, because think money. Suppose that you owe $7 to someone. You have $3 in your right pocket. You owe $2 to somebody else. You have $8 in your left pocket, and you owe $1 to some third person. Now, in the net amount of what you have would be the same as saying that you have $3 in your right pocket, you owe $1 to some person, you owe $7 to another person, you owe $2 to a third person, and you have $8 in your left pocket. In the end, the amounts that you owe and the amounts that you have are the same, and your net worth should come to the same thing. And as a third sequence, we could start with all of the additions. I have $3 in my right pocket, $8 in my left pocket. I owe someone $7. I owe someone else $2, and I owe a third person $1, and that would also come to the same thing. So addition and subtraction, it's not the case that addition has to be done before subtraction, which is what BEDMAS implies. You could actually subtract first. I could do all of my subtractions first and then add 3 and 8. Or I could do a mix of them. I could subtract 7, then add 3, then subtract 2, then add 8, and then subtract 1, as this statement says. And all of them would give you the same answer. So that's another problem with BEDMAS. Again, it leaves the impression that additions have to be done before subtraction. That limits the ability of a student to manipulate expressions, and it sort of suffocates the ability to think in different ways. And the same is true with multiplication division. Here is an example of a chain multiplication division. And again, we can see this expression as 1 times 8 times 6, divide by 3, divide by 2, times 5. And we could change the sequence if we wanted to, so long as the operation that sits before the number is carried with it. So we could write this down as 1 times 5. So with multiplication division, we always begin with either 1 times or 1 divided by. With addition subtraction, with 0 plus or 0 minus. And so here we could start with 1 times 5, which is the same as times 5 that we have here. Then divide by 3, which matches division by 3 here. Divide by 2, and that's the same as division by 2 here. Times 8, again, matches times 8 here. And finally times 6, which is the same as times 6 here. Now, for me to show you that these will give you the same answers, let's take a look at the top sequence. Here we have 1. Then we have times 8, and then times 6. So I'm following this sequence here right now. So let me clear it up one more time. This sequence, that's 1 times 8 times 6, divide by 3, divide by 2. 2, and then times 5. And the answer is 40. Now remember that. The second sequence down here will also evaluate 240. Let's see. We have 1 times 5 divide by 3 divide by 2 times 8 times 6, and that's equal to 40. So as you can see, either sequence works. And again, it's not the case that multiplication has to be done before, division has to be done before multiplication, which is what BEDMAS implies. And again, that kind of thinking limits the ability of the student to think of expressions in different ways and even work them out in different ways. Here's another sequence that's the same as what we had above. 1 divide by 2. Again, you notice that division by 2 stays the same in all three expressions. Then divide by 3 times 5 here and here. There is times 6 here and here, and there is times 8, which is here and here. And I would like to even try the last sequence to show you that we get 40 again. So if we have 1 divide by 2 divide by 3 times 5 times 6 times 8, and we get 40 again. So again, the order of multiplication and division can be changed so long as you pay attention to what is being multiplied and what is being divided by. Okay. Now, the third problem that I have with BEDMAS is that it can be very confusing. Even for people who are seasoned, it can be confusing. And to give you an example of a few examples of how it can be confusing, let's take a look at 3 expressions. 9 minus 2 plus 3, which seems simple enough. Then there is 24 divided by 4 times 3. And then there is 8 divided by 2 multiplied by bracket 2 plus 2. Okay, let's take a look at each of these in turn. So the first one, which is 9 minus 2 plus 3, this one can be pretty confusing because with BEDMAS, addition comes before subtraction, and therefore the implication would be that we should add 2 and 3 to get 5 and then subtract that from 9. This is in fact incorrect. And it's interesting that the person who brought this to my attention was actually a physicist. She came up to me one day and said that she has found a problem with BEDMAS, and BEDMAS implies that addition should be done before subtraction, which means we get 9 minus 5, and that it's incorrect. And of course, the answer to that is that the view that 2 and 3 should be added is incorrect. The proper way to look at this expression is that you subtract 2 and then you add 3. And in that way, and you can do them in any order, both of them will give you the same answer. Both of you will give you 10 as the answer. You can see, for example, if I start with 9 and then subtract 2, I get 7. Then 7 plus 3 is 10. I could also start with 9 and then add 3 first. That gives me 12, and then subtract 2, which gives me 10 again. And so again, you could do addition before subtraction, as BEDMAS says, and that does work, except if you look at the addition as addition of 2 and 3, then it will not work. And also another advantage of this approach is that it does teach you that you can do addition and subtraction in any order that you want. It doesn't have to be addition before subtraction. So indeed, you could go from left to right. 9 minus 2, 7. 7 plus 3, 10. Okay, the next example is 24 divided by 4 times 3. Now, I'm not quite sure if I can blame BEDMAS for this, because BEDMAS happens to be pretty clear about the fact that division comes before multiplication. So you need to divide 24 by 4 to get 6, and then multiply by 3 to get 18. The only problem is that it's so easy for us to imagine that we need to multiply 4 by 3. and then divide 24 by it. So the impression that we get 24 divided by 12 is pretty strong. I have to admit sometimes I fall into that trap as well. It's because multiplication is easier than division, and somehow we just start with that. However, with BEDMAS, the idea is that you divide first, so you get 24 divided by 4, which is 6, and then multiply by 3 to get 18. Now, on that note, this is one reason why we don't use the double dot notation for division in science formulas, and the reason for that is because of this kind of confusion. What we prefer instead is to use the horizontal line for this kind of display. So as an example of that, we would write down the division that you see. I'm going to repeat it over here with the horizontal line for division. This would become 24, and then you would divide this by 4, and then you would multiply this by 3. And you notice that in this case there is no way I would make the mistake of multiplying 4 and 3. 4 is being divided by, 3 is being multiplied by. And you can also work out this expression in 2 different ways. You can start with 24, actually in more than even 2 different ways. You can start with 24 and divide that by 4, then multiply the answer by 3, or 24 times 3 and then divide by 4. You can even start with 3 and divide by 4, then multiply by 24. All of them will give you the same answer. But the mistake that happens here, where people might think that they have to multiply 4 and 3, it sort of doesn't happen that often here. Most people know that 4 and 3 don't get multiplied. Okay, now let me remove what I just added here. And the view that we have for this expression is that you divide by 4 and you multiply by 3. And again, you can do these in any order that you want, and both of them will give you 18. Let's take a look at these orders. So if I start with division first and then multiplication, of course I get 24 divided by 4, 6, and 6 times 3 is 18. If I start with 24 times 3, I end up with 72. Let's see, 24 times 3 is 72. And then we divide by 4, and that gives us 18 back. Divide by 4, and that's equal to 18. So you can do them in any order that you want. And the third one, this one has actually been making the rounds on the internet these days. How do you work out 8 divided by 2 times bracket 2 plus 2? And I guess the first step where we have to do the brackets is something that most people do. And so we end up with 8 divided by 2 times 4. And now here a lot of people argue that we have to multiply 2 by 4 and write down 8 divided by 8, which is not correct. I think the reason this happens is both a combination of thinking that multiplication being easier than division, and therefore that has to be done first. And also, I think what happens with some people as well is that the B for brackets, they think that they have to work out the bracket, and for that to do that they have to multiply 2 by the bracket. Whereas keep in mind that brackets in BEDMAS mean that you should work out what's inside them. What's outside brackets follows the rest of the letters in BEDMAS. That would be BEDMAS. In fact, once you've worked out the 4, then B for brackets is done. It's finished. Now you have to move on to either exponents, division, multiplication, addition, or subtraction. And so the proper way to see this would be to see this as 8 divided by 2 times 4. And then you realize that you can do your division by 2 and multiplication by 4 in any order that you want. That gives us 16 as the final answer. So for example, 8 divided by 2 is 4, and 4 times 4 is 16. Or you could do 8 times 4, which is 32, and then divide by 2 to get 16. Okay. So that's the third reason why BEDMAS is not a good approach, because it can be confusing. Although again, it does work. There is nothing wrong with it. Number 4, BEDMAS is not needed. In fact, it is possible to work out expressions by just being able to find the main operation and then working out the arguments of that operation. If we have a problem such as 24 over 12 in brackets to the power of 3, BEDMAS would say brackets first. Don't ask questions. Don't ask why. You have to do brackets first. And so we do 24 divided by 12, and we get 2 to the power of 3. And then BEDMAS says exponents next. Again, don't ask why. You have to do it now. 2 to the power of 3 becomes 8. So we did it, and we got the answer. But it's not as satisfying as if I adopt the point of view that when I take a look at this expression, I can see, this is an exponentiation. I'm trying to raise a number to the power of some other number. And of course, in order to work it out, we have to know what number we have as the base and what number we have as the exponent. So we have to work those out. These are the arguments of the exponentiation. And therefore, we work out the base, which is 2. That comes from 24 divided by 12. And then we do the exponent, which is 3. And now, once we have identified the main operation, we have worked out its arguments, then we perform the operation itself, and we get 8. This is much better than just saying, oh, brackets first. We don't know why, we just have to do brackets first. And then exponents, that's what we have to do. It's like one of my students, when I asked her, do you know why we follow the order in BEDMAS? And she said, sir, we don't make orders, we just follow them. And that's not the way to learn math. Okay, number 5. BEDMAS is limited. Where is R for roots? If my expression has exponents, roots, this division, multiplication, addition, subtraction, where does R fit in this sequence? What about L for logarithms? S for sine, never mind that it clashes with S for subtraction, so we would have to come up with some other letter for sine. There is C for cosine, and so on and so forth. What about these ones? Number 6, BEDMAS is inefficient. Now I have a fair amount to say about this one, and I'm going to do so through examples. Let's say we want to evaluate this expression, -3 times -4 times 2 plus 2 times -5 times 2 minus 4 times -3. I'm going to use first probably the worst version of BEDMAS, which is the step-by-step BEDMAS. And that's the one that says you go from left to right, and on each time you perform only one operation according to the rule BEDMAS. And so going from left to right, we notice that we have multiplications, additions, and subtractions only. Then multiplication comes first, and therefore we go from left to right and we find the first multiplication, -3 times -4. Now notice how much writing and how much thinking goes into working this, I would say, rather simple expression out. You will see how simple it is once I teach you how to work it out using a different approach. So here we say negative times negative is positive, and that 3 times 4 is 12, and therefore we write down there we go. So we write down 12, and then 12. Then we have to repeat everything else. 12 times 2 plus 2 times -5 times 2 minus 4 times -3. Now we go from left to right and do the next multiplication, which is 12 times 2, 24, and then we write down plus 2 times -5 times 2 minus 4 times -3. And then from left to right, of course, we have to do the multiplication 2 times -5. So let's write down the plus. And then we do 2 times -5. Now here we have positive times negative, which is negative. And then 2 times 5 is 10. So we have -10. And then we continue writing the rest of the expression. Times 2 minus 4 times -3. Going from left to right, there is 24. That's an addition. And then we have a multiplication here. So we multiply -10 by 2. That's negative times positive negative. So we get -20. 24 plus -20 minus 4 times -3. And then again going from left to right, and by now I don't even know why I'm doing what I'm doing. The story is lost. I'm trying to figure out what operations next and what I have to do next, and negative times positive is negative and all of that, that I lose track of what it is that I was doing. Fluency suffers. When people do problems like this, they're not fluent. Even if they get the answer, okay, fine, they have learned their skill, but I would question whether that skill is as functional as some much better skills that they can have. Alright, we continue from left to right. We do have a multiplication 4 times negative 3 here. So we write down 24 plus negative 20 minus and then negative 12. Now we have to argue that adding a negative number is the same as subtracting it. So we write down 24 minus 20. And we have to argue that subtracting a negative number is the same as adding it. So we put down plus 12. Going from left to right, now we have taken care of all of our multiplications and divisions. And by the way, cleaning up the signs was, or working out the argument, adding a negative number, subtracting a negative number, was nowhere in BEDMAS. So we get now additions and subtractions, and again, hopefully we won't make a mistake of adding 20 and 12. You subtract 20 and you add 12. So I'm going to go from left to right. At least let's say this person knows that you can do addition and subtraction in any order. So we end up with 4 plus 12. And that gives me 16. And finally, I take a look at the back of the book. It's correct, and I feel like I know math. Now, a much more efficient version of BEDMAS is to just do as many multiplication as you can in one go until you come to a plus or a minus. So following this approach, people would write the same problem, the solution to the same problem. First, they would start with negative 3 times negative 4, which is negative times negative positive 3 times 4, 12. And then they wouldn't stop there. They would multiply 12 by 2 because there is another multiplication. There is a chain here to get 24. And they would write down 24. And then plus. And then they would say 2 times negative 5. That's positive times negative. Negative 2 times 5, 10. So we have negative 10. Let's also multiply 2 at the same time to get negative 20. And we write down plus negative 20. Then minus. And now we multiply 4 by negative 3. That's positive times negative negative, and 3 times 4, 12. So they sort of jump down to here, which is nice actually. This is much better than the step-by-step BEDMAS. We still have to argue that we have 24, and then adding a negative number means subtracting it, and subtracting a negative number means adding it. And then again, hopefully we know that we shouldn't make the mistake of adding 20 and 12, although BEDMAS seems to imply that, because addition comes before subtraction. But we see this as subtract 20 and add 12, and if we know that we can do this in any order, then we can just do the whole thing in one and say 24 minus 20 is 4 plus 12, 16. Okay, so if BEDMAS is not such a good approach, then what's the alternative? The alternative is the analysis synthesis technique. When you analyze something, you break it down into its logical components, and then you break those components into their logical components, and so on and so forth, until you arrive at the smallest components, which for expressions are the numbers, the individual numbers. Synthesis means when you synthesize something, you put it back together. You start with the small components, put them together to make bigger components, and then you put those bigger components together to make even bigger components until you arrive at the main object that you're trying to make. What you will notice is that BEDMAS corresponds to the second stage, the synthesis stage. And that's why the operations appear to be backwards from the most difficult to the easiest, at least until we get to AS part. Now let me show you how you would work out the problem that we had above using the analysis synthesis technique. Now here, what we do is we begin with additions and subtractions outside brackets. We are trying to break the whole expression down into its logical components. And the way we can do that is to find additions and subtractions. If there are additions and subtractions inside brackets, for now we ignore them. So there is one addition here, and there is one subtraction here. And these additions and subtractions break the expression into pieces. We call them terms. Let me show you the terms by placing boxes around negative 3 times negative 4 times 2, then 2 times negative 5 times 2, and then 4 times negative 3. And here they are. We have a jump here. Let me see. Okay, there we go. So now we have negative 3 times negative 4 times 2, and then this is the addition. Term number 2 is 2 times negative 5 times 2, and then we have a subtraction, and then 4 times negative 3. Now to work it out, we have to work out, so the understanding right away comes to us. We have to work out the terms and then add and subtract them as shown. Now, why is it that expressions break along additions and subtractions? because those correspond to the simplest kinds of problems that we solve. They are the kinds of operations that correspond to the simplest kinds of problems that we solve. And these kinds of problems are known as superposition problems. Now, within these terms, this is still the analysis stage. We are breaking the whole expression into its components, which are the terms. And the terms break down into their logical components, which are factors. Now, let me show you the factors. And I'm going to show you the factors by highlighting them. Factors are entities within a term that are being multiplied. For now, we're not going to talk about division, but division can be also dealt with in a similar manner. So what I say about multiplication here, later on, we'll see that for division we can pretty much do the same thing. But for now, let's limit it to the multiplication part. So factors are entities within terms that we multiply. And if you take a look at term number 1, you'll notice that we have 3 of them. -3 is a factor. And there it is. I just highlighted -3. And then this is multiplied by -4, which means -4 is a factor. And there we have it. And this is followed by 2, and that implies that 2 is a factor. We are multiplying these 3 numbers together. So term number 1 breaks into 3 factors. Now term number 2, you may be able to tell on your own that this one also has 3 factors. The first one is 2, and the next one is -5, and the third one is 2. These are the entities within term number 2 that are being multiplied, and each one is called a factor. Term number 3, now you tell me, how many factors? And if you said 2, that's great, I love you. And yes, we do have 2 factors. There is 4, and it's being multiplied by -3. And so for factors now, let me actually highlight these ones as well. We have there we go. We have 4, and then this is multiplied by -3. So 2 factors within the third term. Now you notice that the reason that we break terms along the lines of multiplication is because multiplication is the next most complex kind of an operation, and it corresponds to the next most complex kinds of problems that we solve. Multiplication and division, both of them, have to do with the types of problems that we call proportion. And you can see that the logic is so nice. It's so easy to remember. Find your additions and subtractions outside brackets. Find your terms. And the idea is that these terms would have to be worked out and then added and subtracted. Keep in mind, addition goes with the term that follows. Subtraction goes with the term that follows. Within terms, you find your factors. Now, sometimes factors are done. Like -3 on its own is pretty much done. There is nothing more that I can do to -3 on its own. Same thing with -4 and 2. And in fact, all of the factors, each factor is just a number, positive or negative. But it's not like there is more that needs to be done. And so once we get to this stage, now the analysis stage is done. We now understand how this whole thing is put together. Now we synthesize, and that's where BEDMAS comes in. Now, in order to synthesize or work it out, we would need to work out the factors, which are done, and then we multiply them to work out the terms. Now, you see, we have to do the multiplications here. We have to do the multiplications here. We have to do the multiplication over here as well before we know what it is that we have to add and subtract. This is why in BEDMAS M comes before addition and subtraction. And to work them out now, to actually do the work, there is a much easier way. Rather than following BEDMAS, go from left to right and do one operation at a time, we are going to deal with the whole chain multiplication here in one go. And I have talked about how to do this in my video on integers. So I won't go through the details of why it works. I will just follow the approach that we had. And the approach is basically to count the number of negatives, work out the sign, and then work out the magnitude. For sign, if you have an even number of negatives, then the answer will be positive. If you have an odd number of negatives, then the answer will be negative. In this case, I have 2 negatives, so the answer will be positive. I will not write the positive sign. Now, once you've worked out the sign, then ignore the signs and just multiply 3 by 4 by 2. 3 times 4, 12. 12 times 2, 24. So the argument would be negative times negative positive, and then 3 times 4 times 2, 3 times 4, 12, 12 times 2, 24. And so we write down 24. Now for the next term, there is only one negative. And if this was a minus, by the way, I could speed things up by counting it as a negative as well. But right now there is only one negative, so the answer will be a minus, and we just put down minus. Now that we have worked out the whether it's addition or subtraction and the signs are done, we multiply 2 by 5 by 2. 2 times 5, 10. 10 times 2, 20. And we write 20. And here we have two negatives. We do count the subtraction that applies to the term that follows as a negative to speed things up. This in fact combines the rules for multiplication division of integers and addition subtraction of integers into one, and we end up with a plus, so we write down plus. And then 4 times 3, now you can ignore the sign, 4 times 3 is 12, and therefore we get 24 minus 20 plus 12. And you can see how this whole complicated looking expression became such a simple thing in one step, so easy to check. Two negatives, that's even, the answer is positive. 3 times 4, 12, 12 times 2, 24. Next, one negative, it makes it minus, and then 2 times 5, 10, 10 times 2, 20. Two negatives, I do count the subtraction here to speed things up, that makes it a plus, and then 4 times 3, 12. So easy to work it out, so easy to check, and so much confidence in what you're doing. And later on you'll see that there is so much meaning that we can associate to these boxes, which are the terms and the factors. And now we go from left to right. We do understand we're not following BEDMAS. We do understand that we need to subtract 20 and add 12, and that we can do them in any order. And therefore I choose to subtract 24 minus 20, which is 4, and then add 12 to get 16. And there you have it. All right, another example. Now here we want to evaluate a chain multiplication of fractions. And if I follow BEDMAS, of course, again I go from left to right, and I have to do the multiplications. There is only multiplication present anyway, and that means I have to multiply 13 over 14 and 9 over 11. It would be a good idea to reduce if we can before we multiply it, but in this case nothing reduces. 13 and 14 don't reduce, 13 and 11 don't reduce, 9 and 14 don't reduce, and 9 and 11 don't reduce. So we end up multiplying the top numbers and multiplying the bottom numbers to get the answer. Now multiplying the top numbers will give me 117, and multiplying the bottom numbers gives me 154. And now already the problem is becoming annoyingly annoying because 117 over 154, how does one work with these kinds of numbers? And sometimes they might happen, sometimes there may be no way around it, but at least if we can sort of simplify things ahead of time a bit, that would be preferred. Can I reduce 117 with 154? Well, if I know my fractions well, then I would say no, because they came from here and I couldn't reduce anything here. So 117 over 154 has already been reduced to lowest terms. But I cannot really tell, is there something common to 117 and 26? They look like they have nothing in common, but you never know. Same thing with 7 and 154. 7 and 26 we can probably tell have nothing in common. So what's a better way of doing it? Again, keeping in mind that we can do multiplication in any order, I choose to, instead of multiplying 13 over 14 by 9 over 11, I choose to actually reduce 13 and 26. And it's so easy to see that 13 goes into 13 once, into 26 twice. And 7 and 14, 7 into 7 once, into 14 twice, before I multiply. You see, BEDMAS, by insisting that you have to go from left to right, forces you to do 13 over 14 times 9 over 11, and now you lose your chance to reduce 13 and 26 before they become big, before you end up with 117, right? Same thing with 14 and 7. I could have reduced them here before I multiplied 14 by 11 to get 154, which is now I don't even see 7 goes in. Like if your times table is good, you may see that, but for 117, I personally cannot see that 13 goes into it, but it does. Now if I reduce, let's say 13 and 26, I can argue that 13 into 13 is once, and 13 into 26 goes twice. So I would cross out the 13 and put 1 on top, so 13 into 13 once, and then I cross out the 26 and put 2, 13 into 26 twice. And I can reduce 7 and 14 as well. I can say 7 into 7 once, into 14 twice, and I get 2 for 14 and 1 for 7. And now I cannot reduce anymore, so I multiply the top numbers to get 1 times 9, 9, and 9 times 1, 9. Down here we get 2 times 11, 22, and 22 times 2, 44. So the answer is 9 over 44. It wasn't a difficult problem, whereas BEDMAS turned it into an extremely annoying kind of a problem. So here it's not quite clear how we can continue. All right. Now the last reason why BEDMAS is not a good approach is because it is semantically deficient. It means it's difficult to get meaning out of what you do. And again, the reason is because you get caught up in so much in what do I have to do next, multiply. No, BEDMAS says exponents, that meaning gets lost. Take a look at this word problem. This morning you drove at a speed of 120 kilometers per hour for 2.5 hours. This afternoon, you drove at a speed of 90 kilometers per hour for 1.5 hours. What total distance did you cover today? And we can say that we can solve this problem or write an expression for it like this. 120 times 2.5 plus 90 times 1.5, and we would like to work it out. Now, first of all, one problem with BEDMAS again is that it doesn't teach you how to put sentences together, statements together. It does teach you how to work them out. And that becomes a problem when you want to take a word problem like this and write an expression like that. And BEDMAS would say, okay, suppose somebody worked this out. Now we want to add and subtract. So we go from left to right, multiply 120 by 2.5, we get 300. Let's go from left to right again. There is a multiplication. Let's do that one. You see, we're not asking why. Why is it that we are multiplying? All we do is just go from left to right and do whatever it says. 90 times 1.5 becomes 135, and then add them up to get 435. Now, if we follow the analysis synthesis technique, then we would immediately, first of all, we would be able to write this down ourselves with a bit of practice. And then we would immediately see this as two terms. And if I can draw boxes around them, there we go. Term number 1, term number 2, broken up by addition. And we immediately know that we're adding these two. And why is it that we're trying to work them out? And we notice that this would give us the distance that I covered this morning by multiplying my travel speed and travel time. I find the distance that I covered this morning. And this other term gives me the distance that I covered this afternoon. And once I know the distance covered this morning and the distance covered this afternoon, then I can add them up to find the total distance. We work out the two terms both at once, and we get 300 kilometers that we covered this morning, and in the afternoon we covered 135 kilometers, and then we add them up to get 435 kilometers in total. Okay, so the analysis synthesis technique, at its simplest, by the way, it's just one step that you keep repeating, and that single step says find your main operation and work out its arguments. Now, when you work out the arguments, you may have to reapply the steps. For those arguments, find the main operation and work out their arguments, and so on and so forth. And this sort of strengthens the ability to find out how to write things down on your own. However, here, before we get to the point where your background is strong enough to understand how to work with the main operation, I'm going to show you sort of like a longer version, but it's easier to use. So step number 1, there are two main stages, of course. Analyze, which means break it down. You break the expression into terms using additions and subtractions outside brackets. Then you break each term into factors, which are things within terms that you multiply. For now, we're not going to talk about division. And then you break factors further if needed. Stage 2 is, now that you have an understanding of how it breaks down, put it back together. Synthesize. And it starts with the simplest of the elements, which are the factors. We work them out. And then we multiply the factors to evaluate the terms. And then we add and subtract the terms to evaluate the expression. Here is an example. 4 times 2 plus 5 times 6. So we have an addition. We break the expression into terms. The addition breaks it up. Additions and subtractions break an expression into terms. and we end up with two terms. We work out the two terms to get 8 plus 30, and then we add them up to get 38. Now you see, if I have a word problem that says I bought 4 pens at $2 per pen and 5 notebooks at $6 per notebook, how much did I spend in total? I can actually write the expression that we had above for it. 4 times 2, because I understand that this becomes the terms 4 times 2 and 5 times 6. 4 times 2 tries to figure out the total amount of money that I spent on the pens. 5 times 6 finds the total amount of money spent on the notebooks. And once I find out how much I spent on the pens, $8, and the amount of money I spent on the notebooks, which is $30, then I can add them up to come up with a grand total of $38. So in total I spent $38. Okay, as a second example, let's put some negative numbers in there. Now that's one reason for multiplication we prefer to put our numbers in brackets. In fact, this is a good time for me to mention that if you put down 3 and then times -2 and then times 4 and then subtract 4 and then times 6 and then times -3, this becomes a bit annoying to try to find the terms, because you see the signs and the subtraction, the negative sign and the subtraction sign, they get in each other's way. I cannot look at this at a glance and say, this is a sign and this is a subtraction. With this style of writing though, because negative numbers are placed inside brackets, it's pretty easy to tell that this is a sign, this is a sign, and this is a subtraction. Moreover, it's my personal preference to also put a bit of empty space on either side of a plus or a minus to make the terms stand out. So much better notation here up here compared to the one down here. Okay, let me actually remove what we have, what I just added. Alright, so we have a subtraction, and it breaks the whole expression into two terms, and there they are. Term number 1, work out the sign, then the magnitude. It will be negative. 3 times 2, 6. 6 times 4, 24. So we will have -24. This one will be positive, 2 negatives. And then 4 times 6 times 3 will be 72. And we end up with -24 plus 72. Once again, an odd number of negatives, minus. 3 times 2, 6 times 4, 24. An even number of negatives, plus. 4 times 6, 24. 24 times 3, 72. Now we add and subtract to end up with 48. Okay, here's another one. We have -2 times bracket -5 minus 3 times 2 plus 4 times bracket -6 times 2 minus 3 times 5. Now this one has only one addition outside brackets. Initially we don't look at additions or subtractions inside brackets, but only outside brackets, and so we will end up with two terms, term number 1 and term number 2. It is very important to be able to tell the factors within the terms, and these are things that you multiply. Here in term number 1, the first factor is -2, and then this is multiplied by bracket everything that you see here within the brackets. That's another factor. So this is the point of view that we have, that we are multiplying -2 by whatever the bracket has in it, which explains why we have to work out the bracket before we can multiply -2 by it. Now within brackets, of course, you have two terms. There is a subtraction, and so the same rules apply within brackets. Term number 2, we have a 4, that's factor number 1, and then following that we have bracket the whole bracket, -6 times 2 minus 3 times 5. That's factor number 2. So we have broken the expression into terms. The understanding is that we have to work out the terms and then add them up. Within term number 1, we have to multiply these two factors, and within term number 2, we have to multiply these factors. Now we have to work out the factors. This is when BEDMAS comes in. You work out brackets, you work out the factors. That's how we see it. Factor number 1 is done. Factor number 2 breaks into two terms. We work out the terms to get -5 minus 6. Term number 2, 4 is done. Factor number 2, we work out -6 times 2 to get -12, and then 3 times 5 to get 15. So we write down, now let's go through it one more time. We have -2, and then factor number 2, we have to work it out. It has two terms. there is -5, and then 3 times 2 is 6. Here, factor number 2 has 2 terms, -6 times 2, -12, 3 times 5, 15. We still have to work out factor number 2 here and factor number 2 here. And why don't I highlight them again? The risk of making this video even a bit longer, but it's actually a very good practice. This is one of those key videos that I have. So we have factor number 1, and then -5 minus 6 is factor number 2. So there you have it. And then within the next term we have 4. Still the factor is waiting for the next factor, which is brackets, to finish. So then we can multiply them together. So we still have to work out the second factor here and the second factor here. And so we put down -2, and then the second factor becomes -11. Here factor 1 is 4, and factor number 2, it should have been -27. So let's make that correction here. Right. Okay. And I guess I have to make another correction next. So here we have negative times negative. There are 2 negatives and even number of negatives, which is positive, and then 2 times 11 is 12. You see how easy it is to fix the problem. So I have 4 times -27. There is 1 negative, and it should be a minus and not a plus. So let's replace that with a minus. And then 4 times 27, now that's 108. Okay, so we replace this with 108. Let me double check. 4 7s 28, and then 8 and 2 10. And so we have 22 minus 108. Okay, for 22 minus 108, we're going to work it out, and again, I guess we have to make another correction now. Now 108, we can make it 100, and 22, if you take away 8, you get 14. So 1476, I believe. Okay, let's make that correction as well. And there you have it. You see, so easy to fix a problem if it comes up. And with so much confidence. Now let me just double check. That's -76, and that gives me, or -86. Yeah, okay, so we have -86 for this problem. All right, next example. Now this time we have exponents. There is one subtraction, and that breaks the expression into 2 terms. Term number 1 is 4 to the power of 3. Term number 2 is 2 times 3 to the power of 4. Now let's just take a quick look at our factors. Term number 1 has only one factor. 4 to the power of 3 is seen as one factor. Now you might say, well, we can write it down as 4 times 4 times 4, and isn't that 3 factors? And the answer is yes. If you write it down as 4 times 4 times 4, then we see that's 3 factors. But as if you put down an exponent like this, we prefer to see this as one factor. Okay, term number 2 breaks down into 2 factors. The first one is 2, and then the next one is 3 to the power of 4. These are the 2 things that we are multiplying within the second term. So now we have the factors which are 4 to the power of 3. In the second term we have 2 factors, 2 and 3 to the power of 4. The analysis stage is done. Factors, now we have exponents. 2 of them have exponents in them. Now we go back to the synthesis stage, which means that we work out the factors. 4 to the power of 3 becomes 64. This factor is just 2, and 3 to the power of 4, you multiply 3 by itself 4 times to get 81. And so the next line is here. Factor 4 to the power of 3 is done, 2 is done, 3 to the power of 4 is done. Now that the factors have been done, we work out the terms. Term number 1 is just 64, that's done. Term number 2, we multiply 2 by 81 to get 162, and then we subtract to get -98. Okay, here's one with fractions in them, rational numbers in fact. So we have one addition outside brackets, and this breaks the whole thing into 2 terms, and the terms are shown here. Okay, we work out term number 1, 2 negatives make it positive, and then the 3's reduce, and we get 1/4. For the next one, we have a plus, there are no negatives, and then 2 over 1, we multiply 2 over 1 by 4 over 5 to get 8/5. And now the least common denominator is 20, and 20 divided by 4, 5, times 1, 5. 20 divided by 5, 4 times 8, 30. And we end up with 37 over 20. All right, we close this now by looking at those three troublesome expressions that we had before. 9 minus 2 plus 3. Now we understand that we have to subtract 2 and add 3. We can do them in any order, so we might as well go from left to right here. 9 minus 2, 7, and 7 plus 3, 10. The next example, 24 divided by 4 times 3. We understand that we have to divide by 4 and multiply by 3, and we can do that in any order. And again, following any order, we end up with 18. And then the third example, 8 divided by 2 times bracket 2 plus 2. We see this as 8 divided by 2. We finish 2 plus 2 to get 4, and we actually see this as 8 divided by 2 times 4, division by 2, multiplication by 4. They can be done in any order, and we get 16. Okay, so once again, the reasons why BEDMAS is not a good approach and why it should be replaced by the analysis synthesis technique. Number 1, BEDMAS is arbitrary. There is no reason why this particular sequence. Number 2, BEDMAS is rigid. It leaves the impression that this is the only way of doing it. Number 3, BEDMAS is confusing. There are certain constructs that can throw people off. Number 4, BEDMAS is not needed. All you have to do is find your main operation and then break the expression along that operation and work out its arguments, and keep repeating that. Number 5, BEDMAS is limited. There is no indication as to how we do roots or logarithms or sine or cosine or tangent or cotangent and all that. BEDMAS is limited. BEDMAS is inefficient. As we saw, especially the step-by-step variety can take forever, and you get lost in what you have to do, so that the storyline totally gets lost. And number 7, BEDMAS is semantically deficient. You get so much into what to do next and what to do first that you forget about the big picture of why it is that you're doing what you're doing. Okay everyone, any comments on this video will be very much appreciated, and thank you so much for watching. And for now, I will be gone in 3, 2, and 1.